Look at a modern desert city. A century ago, packing millions into glass towers surrounded by blistering sand would have been physically impossible. For almost all of human history, heat was a hard boundary. It dictated where people settled, when factories operated, and how large a city could realistically grow. To endure those months, early architecture had to work alongside the weather. Builders relied on deep shaded porches, thick walls, and high windows designed to catch a crossbreeze and naturally vent hot air. Then, in 1902, an engineer named Willis Carrier built a machine to bypass the climate entirely. But the machine that eventually conquered the outdoors was never intended for human comfort. Carrier was hired to solve an industrial headache at a printing plant in Brooklyn. The humid summer air was causing paper to expand and contract, making it impossible to align colors accurately on the press. By inventing a system to strip moisture from the air and stabilize those ink colors, Carrier inadvertently figured out how to seal off the indoor world and control it. The public got its first real taste of mechanical cooling inside movie theaters. Owners realized that advertising cold air was a highly effective way to lure people out of the sweltering streets. Summer used to be the worst season for the film business, but by marketing refrigeration as the primary draw, theaters proved that people would pay for indoor entertainment even in the height of summer, creating the year-round release schedule we see today. Once engineers proved they could reliably manipulate the indoor climate, architects realized they no longer needed to design buildings that interacted with the outside air. This led from Recley to the creation of the modern office tower. We started building dense, towering blocks wrapped in glass, with windows that stayed permanently shut. Because natural ventilation was no longer required, developers could build deep interior spaces, like enclosed shopping malls, where thousands of people could gather while remaining totally detached from the weather outside. But this comfort required a significant electricity load. Maintaining these artificial environments meant machines had to run constantly to fight off the heat pressing against the walls. We stopped adapting our structures to the local climate. Instead, we started relying on a constant supply of energy to overpower it. That ability to overpower the weather soon scaled up to the geographic level. Entire regions that were once considered too punishing for year-round work suddenly morphed into sprawling urban centers. This map shows the demographic shift that followed. Throughout the mid-20th century, millions relocated from the cooler Northeast and Midwest down into the American Sunbelt, drawn by new jobs and newly cooled homes. And when people move, political power moves with them. As populations swelled in the South and West, those states gained congressional seats and electoral votes, steadily pulling the country's political center of gravity toward the Sunbelt. Down at the neighborhood level, daily life moved indoors. Instead of gathering on front porches to catch an evening breeze, families moved into private, sealed living rooms. This changed our expectations of the environment. Today, many of us simply assume that the indoor climate should remain identical every single day of the year, regardless of the weather outside. In just a few decades, cooling technology managed to sever our daily connection to the natural world, while quietly redrawing the political map. Today, as global incomes rise and temperatures spike, artificial cooling has transitioned from a luxury into a tool for survival in the world's most crowded cities. But there is a self-defeating loop in this reliance. The heavy electricity load required to keep these billions of indoor spaces cool is largely generated by burning fossil fuels. This chart shows the feedback loop. Air conditioners draw immense power, releasing greenhouse gases and pumping waste heat into the streets. This pushes outside temperatures higher. The hotter it gets, the more we rely on air conditioning, feeding energy demand back into the loop. Along the way, we largely stopped using the clever design methods that helped humanity tolerate the heat for centuries without using any power. We cannot survive the future by endlessly trying to outrun the weather with raw energy. The smarter path is combining clean power with a return to architecture that actually knows how to live with the climate.